Hi everyone, thanks for joining us this evening. We're going to give it just a couple of minutes for a few more attendees to join us, so everyone sit tight and we will begin momentarily. Okay, everyone, I think we have about half of our attendees logged in. I'm sure a few will be joining us momentarily, so I think we will get started in the interest of time. So good evening, all of you, and thank you so much for joining us this evening. My name is Kayla Carden, and I work in RIT's Office of Alumni Relations. We're so excited to have this opportunity to highlight one of the hallmark programs in the Kate Gleason College of Engineering, Multidisciplinary Senior Design. This program is a tremendous source of pride for our faculty, staff, and students, and it's one of the college's key priorities within RIT's $1 billion campaign, Transforming RIT, the Campaign for Greatness. Today, we are fortunate to have student representatives joining us from 7 of this year's 85 project teams who are eager to share their experiences in the program and especially to answer any audience questions about their work. Before I introduce our first speaker, I'd like to take a brief moment to review a couple of housekeeping items. First, all attendees have entered the program this evening on mute. We have enabled the Q&A function located in the bottom of your screen. We encourage you to submit questions for our presenters and students using this feature. Additionally, keep an eye on the chat box, which is located at the bottom of your screen. We will be sharing links and additional information about the projects being discussed throughout the course of the evening. Now it is my pleasure to introduce you to the Director of the Multidisciplinary Senior Design Program, Dr. Elizabeth DeBartolo. Dr. DeBartolo earned her bachelor's in mechanical engineering and materials science from Duke University, and then went on to complete her master's and PhD in mechanical engineering at Purdue. She has been an associate professor at RIT since 2000, and in September of 2014 took over as director of the MSD program. Beth, with that, I'll turn it over to you.
Great, thank you, Kayla. I'd like to also introduce Don Pofel, who's a lecturer in the Senior Design program, who'll be joining me tonight. He comes to us after many years working in industry at Kodak, and in addition to working with Senior Design, he also spent some time over in the Simone Center where he's a coach in the Applied Entrepreneurship program. So let's start with a brief overview of what Senior Design is all about. So Multidisciplinary Senior Design is a 2-semester course sequence taken by 5th-year students in the College of Engineering. This satisfies our required capstone experience. It's a 2-semester course. The first half is roughly design and the second half is roughly build. Students from biomedical, computer, electrical, industrial, and mechanical engineering students participate. And in addition, if the project lends itself to out-of-college collaboration, we've had students from industrial design, from the College of Business, from applied entrepreneurship in the Simone Center, engineering technology, imaging science, a variety of different areas to help our students work on these real-world problems, which are multidisciplinary in nature. We take a systems approach to teaching engineering design. Students start by defining the problem that they're going to solve so the team and the client can come to a common understanding of what they're working on. Then the teams work on developing their design solution and then shift into build and test, where they actually build a working prototype or implement a functional process, and they test, and then finish out the project by turning all that information over to their client. Each team is mentored by an experienced guide. These folks are generally retired engineers from local industry who have years, if not decades, of experience working as engineers at companies in the area. And they really are an invaluable part of the program because they help bring experience and perspective to help the students navigate not just the technical aspects of the project, but some of the non-technical aspects in the design process.
So our projects are very diverse and they come from many different areas. They come from industry, community, faculty, and students. Some of our projects are outreach projects where we work with clients such as Al Siegel Center, Hilltop Industries, Mary Cariola. We work with community projects and working with Rochester Regional Health, University of Rochester Medical Center, and the George Eastman House. And we also have many corporate clients. So many of the corporate clients such as Kodak Alaris, Optimax, Fisher-Price, and Sandia National Labs as some examples. The thing that's really interesting about this, especially with our corporate clients, is that this is generally a project that the industry would like to get solved. It's not on their priority list as a top priority, but it's something they'd like to get done. And it's quite the deal with regard to a small investment in money and being able to have access to a team of students, and that team of students has access to all the subject matter experts within RIT. The wins for the students is that they get to work with a real corporate client, a real customer, if you will, that has a real world problem that they'd like to solve. And the industry obviously gets a prototype delivered to them and a solution to the problem, hopefully. And also they get the ability to look into our students if they're interested in recruiting for future positions. So we have a process with regard to how the projects come into MSD. First, they come and they get reviewed by the MSD staff in an extended group relative to the functional areas for scope and fit, see whether or not they meet the MSD goals. And then we have the disciplines check it for staffing with regard to, for example, how many electricals, mechanicals, industrial system engineers should be put on each project to make sure that it's staffed appropriately, and staffed for success as well. Students provide input with regard to when they're interested in choosing a project for MSD. Many times they get a choice and they can look at it for project preference. They can see if there's a skill set match for their skill set, and whether or not they choose to work on a project that either they retain their own intellectual property, or in some cases the intellectual property is assigned to a client and they have the ability to make that decision. Team assignments then are made which match the student skill set and the interests of the projects to needs to the appropriate people. And obviously there's opportunity to meet new people in this process, learn to work with others, disciplines. And this is the first time that students really at RIT many times will have the opportunity to work in a cross-functional disciplinary area.
So during the past academic year, 2019-20, we've had nearly 500 students and they completed about 85 projects over the course of the year. Those are some students finishing in December and the majority of them finishing up just now in May. There were more small successes than I can count. One of the interesting things that's come out of this year is that we're aware of 3 of those teams that are preparing to file a provisional patent, either themselves or their client will be filing it on behalf of the team, which is something that we've been seeing more of in recent years. The picture up in the top right is actually a project from last year that got a little bit of airtime this year. This is the Rochester Music Hall of Fame. They're announcing their 2020 class of inductees, but they're doing it from the surface of a Murphy stage that was designed, built, and installed by one of last year's senior design teams. So that was kind of cool to see that one come full circle and actually is getting used. And then the last highlight that we just can't say often enough is we are extremely proud of the way our graduating seniors handled the end of this past semester. They demonstrated dedication, they had such a positive attitude, and they maintained a high level of professionalism through all the challenges that came through at the end of the semester, and really worked hard to see their projects through to completion and deliver something of value to their clients, even if it meant they weren't able to finish prototyping the way they had wanted to. So we're just incredibly proud and honored to have been able to work with them throughout these projects and see them grow and develop and create value for their clients. And we can't wait to see what they do in the future. So what we're going to do next is we've got some videos from these teams that we'll share with you before we open things up for Q&A. At the end of the semester, each team creates a 2-minute summary video, a lightning talk, that gives a quick overview of what their problem was and what their solution was. We're going to share the videos from the 7 teams that we have representatives from participating here today. But if you're looking for something to binge watch in your quarantine homes, you can find links to all of our project videos on the project showcase page, which I believe was shared with you with the invitation for this event. And I think Kayla's going to share that in the chat box alongside this presentation. So you can go take a look at all the other projects. This is just a sampling. There's a lot of cool stuff out there.
Sailbot is a assistive portable sailing device that allows a sailor with disabilities to steer a sailboat with multiple control methods. Currently, Sailbot has 4 different control methods that a sailor could use: a wrist joystick, a thumb joystick, a hand dial, as well as a chin control. This is important because it allows as many users as possible to get a good feel and allows the device to adapt to any disability that it can see. In addition, Sailbot is also a portable device, which is unique because many other devices out there are either proprietary boats, which are very expensive, or hard stuck onto a single boat. But Sailbot's portability allows it to be transported between different boats and allows it to reach as many people as possible. We are currently working with Universal Access Program at Community Boating, and they are a program that allows sailors with disabilities the chance to get on the water and really get this feeling of freedom and control. And our goal was to help further this mission based on some of these issues that we saw with other devices. One of the biggest importance with Sailbot was to make sure it was comfortable and user-friendly, which we were able to do by unique shapes, as well as the multiple hot swappable modules, which allows it, once again, to give as much feedback as possible and adapt to any sailor.
Hi, and welcome to the Arithmetics Lightning Talk video for MSD Project P20095. Our project entails the development of a novel, cost-effective motorized microscope stage attachment that provides remote operability with precise coordinate mapping for digital pathology and telepathology applications.
This project was proposed and sponsored by Augmentics, a digital pathology startup located in Israel that offers a new approach to improving clinical workflow and solving many of the inadequacies of modern digital pathology. The current Augmentics device retrofits to any brand clinical microscope, such as Nikon or Olympus, and captures a 1-to-1 real-time image or video feed of the microscope field of view. In addition, live image and video processing software is applied simultaneously, which can provide useful clinical information to the pathologist within their workflow through an augmented reality display inside the microscope eyepiece. These unique functions allow the Augmentics device to transmit a live interactive telepathology feed from within the microscope environment to anyone in the world.
One of the most requested features Augmentics receives from its clients is the ability to remotely drive the microscope through the telepathology application. This ultimately led to Augmentics proposing an idea to build this new device through the MSD program here at RIT. Through customer discovery and extensive research and development efforts led by our impressive team of 8 engineers, we reached a final solution that we believe encompasses all of the main aspects this device needs to possess. The first key feature is an adjustable motor speed for controlling the XY step size dependent on the current magnification in view. This is to prevent the device from moving too fast on higher magnifications or too slow on lower magnifications. The next key feature is an encoding system that works in conjunction with the stage movement to provide accurate coordinate mapping of the microscope field of view. This feature provides the ability to track and record positional progress for digital pathology and telepathology applications. The last key feature of this device is its cost-effectiveness and retrofitability to pre-existing microscope stage environments. By providing a greater range of accessibility to this device, it drastically improves its chances of being adopted into real-world practice and its overall clinical utility.
The complete Augmentics system with the addition of the RIT Mentix device stands to drastically change the way modern pathology is performed around the world. With the current COVID-19 pandemic illustrating the need for remote technologies, this system can provide rural and third world hospitals access to global telepathology services. This system can further be used for remote frozen sectioning to cut down time in the ER and for global collaboration to drastically improve research and development efforts in clinical pathology.
This has been RIT Mentix, MSD Team P20095, with Brandon Biscaglia
And Markus Tagiar, and we thank you for listening to our Lightning Talk video.
Solar Setting Satellite is a CubeSat that will test solar radiation pressure from diffractive elements for thrust. While the project started with previous teams, the current team made many improvements in the area's deployment and attitude control. The team has predicted a 620-kilometer sun-synchronous orbit to assure constant sunlight on the spacecraft.
The sail consists of 4 triangles made out of mylar. Each triangle is accordion folded into 10-centimeter wide strips and then stacked on top of each other and rolled onto a spindle. The corners of the sails are then attached to 4 booms that form a cross shape and are pulled out from the CubeSat when the booms are extended. After the ice rink test, we decided to try a new packing method for the sails that would have a smoother deployment. We took inspiration from Light Sail 2 and packed the sail into a triangular prism shape instead of rolling it. After a few tests, we ended up changing to a rectangular prism shape instead.
The deployment sensor consists of dual redundant infrared reflectance sensors. Reflective strips are spaced along the boom to give a 5% accuracy. The ice rink was used to test the CubeSat on a low friction surface. A hollow tube is sunken into the center of the rink so the booms are flush with the ice. The circuit boards designed were primarily as prototyping platforms for testing. For attitude determination testing, a custom board was made to mount the rate gyro.
The Raspberry Pi is used to simulate a flight computer. It interacts with the reaction wheels and gyroscopes over a SPI and I2C interface. It controls the sail deployment by sending commands to an MSP430 board. The Pi also has a GUI to record and graph data. The Pi can be accessed over RIT Wi-Fi.
To manufacture the CubeSat, we machined the frame using the RIT Kate Gleason College of Engineering machine shop. Unfortunately, the manufacturing for the attitude control system was not completed. For the attitude control system of the CubeSat, we started with the requirement that the CubeSat must have at least 3 degrees of freedom orientation control. This is necessary to orient the CubeSat after P-pod ejection to begin the experiment. Eventually, we spec'd out the COTS component from NanoAvionics.
Although the team was not fully able to complete the project due to COVID-19, it was an overall success. RIT Specs will be able to continue our work and further advance solar sailing technology. Special thanks to the multiple teams and people that helped us throughout the process.
Of the 2,000 satellites orbiting Earth, most of them are in low Earth orbit. Project Lasso uses time difference of arrival to track and perform orbit determination on low Earth orbit satellites around 437 MHz. Our goal is to track the RIT Specs CubeSat once it's launched and possibly create a hobbyist tracking network similar to this TDOA Lightning Alert network.
3 ground stations will be arranged to form an equilateral triangle. Since each station has a different distance from the satellite, the signal will arrive at different times, which will be used to localize the satellite.
Our system uses a QFH antenna, which has a wide field of view. The antenna and Joey section will be placed together outside, high up, to reduce interference. Here we have a low noise amplifier, a GPS to locate the station and get the current time, and a lightning arrestor to protect the system from strikes. The Joey section will be protected in a weatherproof container once finished.
The hopper box can be farther from the antenna. Since some sites may keep it outside, we used another weatherproof box. The software-defined radio captures the signal. The Raspberry Pi interfaces and controls other devices. The surge protector safeguards against voltage spikes and will give backup power during quick outages. A PoE injector and splitter will be added to regulate power.
Once the signals are sent to RIT, the RIT server will locate the satellite. In future iterations of our project, Lasso will find the satellite's orbital path. The user will use the GUI to download the ground track saved by Lasso.
Before any mounting can occur, Lasso will conduct site surveys at each of our locations: the University of Rochester Mies Observatory, Williamson High School, and Geneseo Community College. These form an equilateral triangle which is best for TDOA. Lastly, thank you to our sponsors, specifically L3 Harris for helping to fund our project. Thank you to our guide, Martin Pepp, for being a great leader and mentor to all of us. And thank you to James Stefano for being our primary subject matter expert.
Every year, RIT's Baja SAE racing team designs and builds a new off-road vehicle for competition. In the past, each new car's speed and torque has been limited by a stock engine that's required for every Baja team to use. A new allowance in the Baja rules permits the use of a hydraulic accumulator system for onboard energy storage and propulsion, which could add a significant performance advantage in racing events. For this project, we've designed a complete hydraulic accumulator system for integration with RIT's 2019 Baja vehicle. A hydraulic accumulator is an energy storage device in which a non-compressible hydraulic fluid can be held under pressure. This pressure is typically supplied by compression of a spring or inert gas. The more volume you push into it, the more pressure is created. In our system, the pressure builds up in the accumulator as the vehicle's wheels turn with the use of a gerotor-type hydraulic motor. The driver can then push a button to discharge the accumulator, sending pressure through the system and into the drivetrain for a near-instant power boost. The system consists of many complex parts that work together to store and release energy. A diaphragm-style hydraulic accumulator, which holds hydraulic fluid under pressure, a low-pressure reservoir where the hydraulic fluid is dumped after the accumulator discharges or in case of a system failure, a system of custom hydraulic manifolds and runs to enable regeneration, idling, and discharging, a hydraulic motor to convert fluid energy into mechanical power, a custom ball ramp and lever arm concentric clutch system to control the coupling of the motor to the vehicle's drivetrain, and a custom PCB and electronics design to control the system in response to driver feedback. Due to the adapted class format in response to COVID-19, we were unable to fully assemble and test the system. Analysis in a detailed and verified Simulink model that represents the Baja vehicle shows up to a half-second reduction in acceleration time, which would provide a significant competitive advantage. Full assembly and testing instructions are provided to RIT's Baja team to enable the project's smooth completion in the future.
$844 million people around the world do not have access to safe drinking water. Direct consumption of surface water and unimproved water sources causes 1 million deaths each year from water-related diseases. The goal of this project was to develop a self-powered UVC LED-based system which can produce enough treated water every day for a family of 5. This system will deliver a minimum fluence of 400 joules per square meter consistently and affordably for its users. The most important component of a UV purification system is the reactor. The reactor is where the LED is located and irradiation takes place. In order to achieve the required fluence, the water must flow through the reactor. Preliminary designs were driven by the cost of the quartz windows and the manufacturability of individual components. These designs were then simulated to estimate this minimum residence time. To test the prototype reactor, iodide iodate actinometry was used. This is a photochemical method where light-sensitive chemicals are used to absorb energy from the UV light and tested to determine the fluence of the UV reactor.
The purpose of the Colombian Aquaponics initiative is to utilize vertical farming to create a low-cost aquaponics system that raises fish and plants together using no electricity and using only materials that are easily sourced in Colombia. Vertical farming aquaponics is the simultaneous raising and harvesting of plants and fish together using stacked structures. The primary benefits to this over traditional farming are cost, time, and space savings. The final prototype satisfies each of the key constraints outlined for the project. The final cost is about $369, which is about $133 less than last year's system and far less than $1,000 commercial systems. All materials can be procured in Colombia at Home Center, and no electricity is needed to operate the system. The manual operation to aerate the system is covered in the next slide.
So the first step in operating our system is to first make sure that the tank is filled up with 70 gallons of water up to this lip here. That the plant bed is filled up, which will be containing lettuce plants here. And then these buckets on either side will also be filled up. From there, you can then remove the duct tape at the bottom, which will start to slowly drain water from the buckets into the PVC plant bed. And from there, the holes placed on the side of the plant bed will slowly drain out. The holes are placed so that there still will be enough water to provide for the plants, but also enough that there will be aeration for the fish. From there, the water will go through the solid filter that we have placed at the bottom of our fish tank. And then this drainage hose is then used to refill these buckets once they empty out in about 2 hours. And then they are refilled on either side, and then the cycle will repeat itself once again.
Great. So now what we'd like to do is open up the floor for some Q&A for those students. We've got representatives from each of the teams here, and some of the students on the list here also have teammates that are available online to answer additional questions. From the satellite tracker team, we've got Anthony Iannuzzi. From the UV water purification is Emerson Maloney. From the CubeSat solar sail is Amber Dubill. Sailbot has Amit Rogel. The automated microscope stage is Markus Dagiar. Hydraulic accumulator system is Nika Garbers. And the aquaponics project is Caleb Wheelock. So what I'll do now is we'll invite the student panelists to open up their video and join us. And I believe Don has some questions.
I do. We have some coming in from our audience already. We got one from Clayton Turner for the Sailbot team. And the question is, what is the interface between the Sailbot and a generic boat? Are there limits to boat size, speed, structure, other?
Thank you very much for the question. So we primarily focused on getting ours compatible for a sonar, and we chose that because that's the U.S. Sailing's official boat for racing with disabilities, as well as the primary boat that community boating works with. We also, one of the nice things is it's a relatively standard size and shape for keel boats, and some of their other boats actually do have the same geometries that we could just use Sailbot and move it to, let's say, one of their Rhodes 19s or Keel Mercuries.
Thank you. So Clayton's got another question for the CubeSat team. Was the original plan to deliver a flyable CubeSat or a ground prototype?
So our original plan was to do a little bit above of a ground prototype, more of an engineering unit for the RT Specs CubeSat that they would continue on after our project.
Okay, thank you. Clayton's got another question for the UV purification team. Is Pure UV one of the technologies seeking a patent?
Indeed, we are. We had our public disclosure a few months ago, and we have a 1-year grace period to file the patent. We have since contacted several patent attorneys and have been working closely with them. However, we will be filing the actual patent next semester after we work a few more things out.
Okay, thank you. I've got some more questions. For the RET Mentix team, what impact do you think your project will have on healthcare?
Yeah, so the current device that Augmentix, the company that funded our project, offers, it's really prevalent right now, especially during the pandemic. They offer a telepathology feature where essentially anywhere in the world, whoever has access to a computer can call in to a microscope that utilizes their current technology to view the specimen that's being reviewed by a pathologist. So this opens the door to second consultations and mainly just other pathologists working together, collaboration for research, things like that. So now with the addition of our device, it gives access to, for third world countries, rural hospitals, things like that, to have access to gold standard pathology around the world at any time. now pathologists can drive the stage as well as view the specimen and give diagnostic assistance to really anyone in the world. So it opens the door for a collaboration for sure.
Okay, thank you. Here's one for the SAT tracker team. How do you determine the optimum distance apart between the antenna locations for a tracking station?
So we had some extensive MATLAB simulations to help us determine the optimum distance. The two deciding factors are the further you put them apart, the less time the satellite is overhead for all three stations. So if you put a station in Rochester and another station in southern Pennsylvania, you're not going to have, oftentimes the satellites can be high in the sky at both places simultaneously, which is challenging for an omnidirectional antenna. As you put the satellites closer together, the time difference, the maximum time difference between the stations decreases. And so if you put the stations very close together, say at two ends of RIT's campus, the maximum time difference might be smaller than your clock synchronization. So there's a fine balance there.
Okay, thank you. Chris Fisher's got a question for the Aquaponics team. What was your biggest challenge with this project?
Really understanding what the conditions needed to be to maintain the proper environment for the fish and the plants. We had an engineer from every single discipline you can have in senior design, but really the main problem was a biology problem. So we had to reach out to subject matter experts, and fortunately we also had a volunteer from the biotechnology department, a third-year student who's from South Korea, and his family actually owns and operates an aquaponics system. So he volunteered his time and expertise to help us and also to take away what he learns from us and bring that back home. So between him and our subject matter experts, Dr. Buckley in the biology department at RIT were really instrumental in helping us figure out how to create the optimal conditions. And we ran small scale testing on buckets just to make sure the conditions could be met before fish were ever introduced. And we were able to meet all of the criteria for proper fish and plant life. Unfortunately, due to the transition to remote learning, we couldn't actually put in the fish or plants, but everything, all the implementation plans and prototypes are ready for the next team to jump right into it.
Okay, thank you. Keep on coming with the audience questions. We're looking to answer a lot more questions. I got a couple more on my end. For the Baja team has done quite a few MSD projects over the past few years. How does the Baja team select these projects and what value do they bring to the team?
Great question. This one actually was proposed by students on the Baja team. So this rule allowance for the hydraulic accumulator systems that was new this year was a brand new thing that we discovered when we were looking at the rules. We knew that no other teams had tried it out before, and so there were just a couple of people from the Baja team that were really interested in giving it a shot. And we also thought that it was a great candidate for an MSD project because it was able to be developed relatively independent of the rest of the Baja project timeline. So we were able to start it way earlier in the summer and then work with the Baja timeline as opposed to the MSD timeline throughout the year to make the project happen and integrate it back with the car at the end of the day.
Okay, thank you. Here's one from Art North. How do you choose the lucky person to drive the Baja car?
Good question. So for testing for our system, like when we're testing the hydraulic accumulator system, we weren't able to test it, unfortunately, because of COVID, but it would have been representatives from our team. For the races, they have an extensive driver tryout process to figure out the best person for each race.
Okay, we got one from, thank you. We got one from Bill Hard. He says for all teams, and maybe a couple of you might want to chime in here, but his question is applicable to everyone. And that is, what was your most important learning from your team's project? So does anybody want to take a shot at that before I start picking on you?
I'll take it. For our project, it was really to think outside of the box, to not be afraid to think of new ideas, because in this industry of aquaponics there's really only a few ways to operate these systems, and that's through electricity. But our key constraint is that we couldn't have electricity. So we went through some really outrageous ideas of using rope pumps and water wheels and seesaws even to try to stimulate aeration for the system, which is the prime responsibility of electricity. But we ended up settling on a much more simplistic view of things and just using drainage buckets. But that simplified view also satisfied our constraint of having a very low cost system. And it's really the main reason why we're looking forward to actually filing a patent for this system, is because it really, there's nothing else out there that is able to create optimal conditions, but not using any electricity. So it really came as just a lot of brainstorming and creativity throughout all my teams and our customer and guides standpoint. So really just not being afraid to step outside of the comfort zone and think of something unique was the biggest thing we learned.
Cool. Thanks, Caleb. Anybody else want to try that too? The same question. What was your most important learning from your team's project?
Yeah, so for Team Lasso, it's a student proposed project. We started out with $1,500 worth of funding, and we have a pretty grand vision of global coverage eventually. So we learned a lot about selling our project to other people, as well as a lot of high system level architecture, because there's nothing, we started with nothing at all, and we built our system from the ground up. So a lot of systems engineering.
Great. Thanks, Anthony. Anybody else want to take a shot at that one?
I'd say not being afraid to stop working on a design that you have been working on for several weeks, if not months, and seeking a new direction. Don't be afraid to do that. We were working on one method of purifying our water with UV light for a good part of the first semester, and we eventually just changed directions to make it more manufacturable, and ended up coming up with a design that we're seeking a patent for, and it will be much better in every way. So not being afraid to let go of things that you've already put work into is very important.
Yeah. Thanks, Emerson. Markus, did you want to answer that one too?
Yeah, really quickly. I just wanted to say, really learning how to adapt to real world situations. I think that's sort of a really cool part of the MSD program, is that it's supposed to be, you know, a real world experience. So it came to a point where we realized we had to do a redesign because some of our, we had a couple moment issues with our project. I think we gave you a heart attack because you were our design. We were supposed to already be building the device, but you know, we sort of just changed our goals, and we're able to adapt to the redesign and get back to a point where we were confident in our project. And the same thing with the pandemic sort of not giving us the ability to fully develop our device, and adapting to that to, you know, get all the documentation done and get it prepared for the customer.
So Markus, while you have the stage, another question for you. How did this project find its way to being your MSD project?
Yeah, it was a pretty awesome story. Well, myself and Brandon, who's also on the team, we're working doing breast cancer research at the University of Rochester Medical Center. And we got to meet the CEO of Augmentics, the company out of Israel. And we sort of started talking to him, and we started working closely with him. And we kind of came up with this idea to for the motorized stage. And they had taken part in the Illuminate program in Rochester. And we were given the opportunity to sort of present a little bit about the current company at the Saunders Summer Startup Program in Rochester, where Dom was able to see our presentation. And we kind of talked to him a little bit about the idea we had, and he gave us the opportunity to apply to the MSD program. So it was very close to the deadline, but we got the submission in, and it sort of became our project from there. And it was cool because we had a really close relationship, obviously, with the company funding the project. So everything was overall an awesome experience.
Great. Thanks, Markus. This one's from Mark Indovina for Caleb. You claim there's nothing out there like this and you can patent your technology. Did anyone do a deep patent search for prior art? And if so, what did you learn regarding the prior art?
Yeah, good question. We really, in all of the design stages, which is all of MSD1, we just kept researching different ways that water could circulate through the system, ideally through a continuous method. In the end, we weren't able to actually come up with a continuous method of water circulation with a fully circulating method, but the system that we have would allow it to slowly drain over a long period of time, which would minimize the amount of effort the worker needs to put into it. In terms of other art, we really didn't see anything out there. Everything else commercially is just all electrically operated. They didn't need to consider this aspect of aquaponics. There's some home systems that we found on YouTube that's where we came up with ideas for rope pumps or water wheels to trying to do this. But in the end, those weren't as feasible given our cost constraints. So the combination of being low cost and using the slowly draining system of the buckets turned out to be the most ideal method for our system. Our customer is currently pursuing the patent through RIT, and RIT would actually hold the patent. I'm not sure where he currently stands with it, but that's the current plan for it.
Okay, thank you, Caleb. From Ron Dufort, for solar sail, what zero G or zero atmospheric issue were considered for unfurling mechanisms and materials in space? I like this question.
Well, I mean, your biggest problem is gravity, especially here on Earth, where when you do solar sail deployment, it's this very thin, flimsy structure that you're trying to, pack in. We had ours in a 1U, so 10 by 10 by 10 centimeters, and then it's unfurls to 16 meters squared. So the problems that we had, we mitigated them by doing that ice rink test that you saw in our video, and there's videos of us doing that at 3 in the morning because it was windy during the day and the ice was going to melt, and the ice had to be perfectly in the right condition to get the best condition. So that's to minimize the friction between the sail and the like what you'd usually see in gravity against a normal surface. Right. And it was interesting because that ice rink is actually custom made. Thank you. I don't think Jared's on the call, but his family, we went to his house. They make an ice rink every year. They took he mentioned that they took a PVC tube, they put it into the bottom of the ice rink when they were making it. And then we went, once everything was frozen over, sawed it off. And there was this hole in the ground so that we could align the sail exactly at where the ice rink level was. And if you see the video with us in the MSD room, that's us using the tables to try to prop up most of the sail to do preliminary testing so that it was at the same level. As far as atmosphere, not too much of a problem, but gravity was the biggest issue there because you can't have it droop down because then that's not really indicative of how it would be in space. And you don't want to over-engineer something, but you don't want to under-engineer it as well. So right. That's where we got that.
Great, Amber, thank you. So there's a couple generic questions up here. I'm going to ask a few more specific ones, and then we're going to open it up for the generic ones for each team to answer because I think they're really good questions. But a couple more specific ones. For the UV water purifier, how would the availability of sunlight affect this project?
Yeah, so in Haiti, which was our primary market right now, because that was where our customer visits often, they don't have reliable electricity for coming from a wall. So we wanted to have it completely off-grid. We explored the use of using like large D batteries, just alkaline, throw away when they're done. It turned out those would be, 8 of them would have to be consumed every day, and it wasn't really feasible. So we ended up looking into a solar battery system where a solar panel would power the system during the day, and when it was done purifying all the water, it would start charging up a battery storage system, and therefore it would be able to either run during the night if they needed it, or it'd be able to run for a few days without sunshine. Pairing this with a solar charge circuit, it was able to, well, theoretically, we weren't able to actually assemble all of the electronics with sunshine. However, it would be able to quickly change from solar power to battery power if a cloud went over or if it was raining for several days. So it should be prepared for most scenarios. Thank you.
Cool. Thank you, Emerson. So Chris Fisher's got one for the Sailbot team. Do you see this project being able to be continued, and what do you feel you can be added to it?
Thank you for the question. Actually, we're still continuing it right now. I have it set up in my garage right now, just because we want to finish it as full as we can. Personally, I think there are some room for improvement. One thing I really liked about the project when I first introduced it was that you can add a lot more control methods. I think there's a lot of other ways that people control like wheelchairs that you could adapt to sailing. And the other biggest improvement that I want to make eventually in the future is to add mainsail control. So currently we are only steering a tiller. And I think adding a mainsail control as well gives a user full access to the boat so they can control whatever they want with our device. And then the second improvement that we could make is try to get it even more cross-platform, start applying it to other boats. Maybe there might need to be certain configuration issues, but our main goal is to try to get it as broad as possible. So I think those are two big avenues we could start to, I guess, approach with Rev 2 and 3 and 4.
Great, thanks, Emmett. While you're there, I got one more for you. This came from your guide, Jim Rittenor. When you found out your sponsor could not supply funding for the project, what did you do?
Oh, so we actually started going and reaching out to local yacht clubs as well as various assistive sailing companies. And we set up a presentation and we talked to people and we got incredible support and incredible donations. And it was really cool. It felt a lot more realistic as well. Like, especially if I ever wanted to pursue a startup, I would have to go out and find funding instead of it just being provided for me. So it was definitely a challenging, and it was stressful at a lot of times when we were designing stuff. It's like, we can't afford this quite yet, but we sought out, we had some incredible donors and we were able to complete the project with budget.
Thank you. So this one's for everyone, if you will. This one's from Adam Platzer. I think it's an excellent question. How do you feel this experience and program will prepare you for your career? Anybody want to take a shot at that?
Would you mind if I took that one?
Please.
What's really cool about this particular project and kind of the MSD process is that you go from beginning to end. You don't get to do that a lot when, if you're going off to, let's say, spacecraft. Spacecraft are usually very, very long projects. So you either start and then get taken off that project or go on to a different one, or you come in the middle and then see it out to the end. And it was really cool that in this setting, we could go through and say, okay, well, here's the idea, here's the inception, here's the design, and now we did get to do some building and testing as well. So going from that whole process view, because I think a lot of engineers don't have the experience of, oh, I understand what the big picture of all this is. And I think that's a very, very cool experience.
Cool. Thanks, Amber. Anybody else want to take a shot at that one?
Yeah, another thing that I think everyone on our team learned was about flexibility in responding to lots of different kinds of challenges. So in addition to the really obvious one, which is COVID and the transition to distance learning and the scope change for the project, we also dealt with a scope change from our customer, actually multiple throughout the course of the year. I know a lot of other people can identify with that too. We dealt with supplier issues. There's one specific place that we really need to get our accumulator from, and they're actually still delayed on a really critical part for the component because of COVID. We dealt with manufacturing difficulties, tooling not being available, so like a wide variety of different things that we couldn't have anticipated at the beginning of the year, but we did try our best to. And the risk management and mitigation and planning that we did up front really helped us be flexible, but also working as a team and communicating really openly about our plans for how to handle each of those things as they came up helped us deal with them throughout the year.
Thank you, Nika. Anybody else? This is, by the way, this is great because we're also answering Chris Fisher's question for all teams, whoever wants to contribute other than COVID. What was the biggest challenge of your project? So these two questions are kind of coming together, right? And you answered both of them. Anybody else want to take a shot at it?
I think, unfortunately, all of our problems that stopped us from actually completing the project were due to COVID, but not directly. So we had to, we ran some preliminary tests and determined that we needed to use a different type of LED. And when we tried to get our LED from our previous vendor, they were shut down and weren't going to be making any more of those LEDs, unfortunately, unless we put in an order of several thousand, which wasn't really in our budget. So definitely the vendor management and having multiple options would be good.
Okay, thank you, Emerson. We got a question from Doreen Edwards, our dean, and her question is, what advice do you have for incoming MSD students? In particular, what insight can you give about the challenges and benefits of working on a multidisciplinary team? Anybody want to take that one? I'm sure should be a lot of good input on that one.
Sure. My team, we had one of every single major and two mechies on top of it. So it was truly a multidisciplinary team. And with that, everyone really had to understand our roles. And that was key in Senior Design 1, is just figuring out, all right, who's going to do what? Because we've all been in projects before within our major, but they've all been specific to our major itself. This project really requires a diverse perspective from each of the people so that was really the key benefit of having a multidisciplinary team, is that you got all these different points of views from different backgrounds. And for my problem in particular, there was no one person that was a specialist in it. So we all got to learn together as one, and that really became a big advantage for our team.
Thank you, Caleb. Anybody else?
Sorry.
Go ahead, Amit.
Oh, thank you. One piece of advice I would give is especially for time management. I was fortunate to be the project manager for mine. Is try to bring maybe like something productive or constructive, no matter how small, every week or every class. And it kind of also ties into when you're looking at your far ahead big goals, to try to break them down into like as little like small achievable steps as possible. One thing that we noticed was whenever we would come in with like even a small thing, like I found a new part we could use, or like I machined one thing, it slowly adds on and has a ripple effect towards the end. When you have bigger chunks of tasks, you notice that all of these like small things you were doing really helped you prepare for the I guess like final push that we had.
Yep. Thank you, Meet.
If I could add one more thing, this is your chance to wear multiple hats. You have students on the team who have spent 4 years in another major, so learn from them.
Absolutely. Anybody else with regard to your multidisciplinary team experience?
I just wanted to say, stay open-minded. I had a team of 8 engineers, so we had sort of 8 point of views all the time. 2 of them were electrical, 2 mechanical, 3 biomedical, and 1 was industrial and systems. So maybe you feel like you're the expert in a certain area, but because they're a different major or whatever, they might have an point of view. So stay open-minded for sort of all parts of the process.
Cool. Thanks, Markus. Anybody else want to take a shot?
Just quickly, there's no stupid questions. We had to, at the beginning of the year, do a lot of adjusting, I think, for people's different expertise in different areas. Some people really knew hydraulics really well. Some people really knew clutch stuff. Some people really knew testing, and being open and kind of leaving our egos at the door about asking questions when we didn't understand something completely was really important in facilitating clear communication.
Great. Thank you, Nika. So I'm going to hand this back to Beth. Don't go away, because we are going to come back to answering more questions, but I'm going to hand this over to Beth at this point in time.
Some people never learn. Thanks, Don, and great job answering the questions, folks. One last thing I would like to ask each of you is really quickly, I'd like to go around and can you just tell us what's next for you now that you've graduated? Nika?
I am starting Monday as a product manager for Cloudflare, which is a tech company in San Francisco.
Cool. Caleb?
I'm moving to Fort Worth to work for Lockheed Martin in their Operations Leadership Development program starting in July.
Emerson?
I'll be moving to California at the end of the summer to start my job at Tesla Solar Roof.
Amber?
I'll be moving to Baltimore to work for Johns Hopkins Applied Physics Laboratory in the space exploration sector.
Anthony?
I'm still looking, but my primary lead right now is the Naval Research Lab Attitude, Control, and Dynamics branch.
Markus? Although I think Markus may have already answered this.
Yeah, I'll be working as a clinical specialist and biomedical engineer for Augmentics, the company that sponsored our project. And I'll be staying local. I should be staying local.
And Amit?
I'm going to be getting my PhD at Georgia Tech for acoustic engineering and music robotics.
Great. So we've got a lot of exciting futures ahead of us. So please join us in congratulating our seniors. They've really done great work, not just in senior design, but in co-op and all their other class projects, and we want to congratulate them. Next, some of you may be wondering, how do I get engaged with this program? Well, there are a few different options. First, you can propose a project. Some of you watching have companies of your own, or you work as an engineer. If you have ideas for problems that are not critical path, but are worth pursuing, and you'd like to have some creative students, creative problem solvers, take a look at them. We are now accepting projects for the 2020-21 academic year, and that activity will be going on all summer. We're expecting another group of 500 students starting, 400 students starting in the fall. So we are looking for projects. Next, you can provide subject matter expertise or mentorship to a team. A lot of our alums are out doing all kinds of cool stuff in the real world. And you know things, and you have wisdom and advice that you can share with our current teams that can help them solve some of these problems that they're looking at. You can provide funding for a team. Projects like Sailbot that come in and they have a community focus, don't have a company sponsor, so we rely on our donors to support projects like that that make a social impact. And then last but certainly not least, when campus opens up again, come visit us. It's great to see these students' faces on the computer screen, and it's great to see their lightning talks, but that's nothing compared to walking into the Senior Design Center and seeing them working on their projects, and they're pulling stuff out of boxes, and they're doing show and tell, and they're showing you how their projects work, and it's really pretty exciting. So please do come back and visit us when the campus opens up again. And then last, but certainly not least, I would like to thank all the supporters who help get our student teams through these projects, starting with the folks on campus. So the technical staff in the ME shop and the Brinkman lab, the construct and the EE and CE senior design labs, the MSD staff, the guides, Gary Hodenius, Chris Fisher, and the lab assistants, Dean Edwards, and the faculty and staff in the College of Engineering who answer knocks on their door for office hours and provide their own subject matter expertise for students. And additionally, we've got lots of partners outside the College of Engineering. So we have folks like Co-op and Career Services that help make connections with potential sources of projects from people who hire our students. We have folks like the Aquaponics team talked with subject matter experts in the College of Science. So we have a lot of folks all across campus who help to make these projects as successful as they are. Next are sponsors and clients. So these are all the folks who came to us and said, we've got a problem and we'd like you to help us solve it. We have a lot of folks from off campus, but also some of the on-campus organizations that bring projects to us. And without them, we wouldn't have interesting problems to solve. And then last but certainly not least, we have some donors who help make a lot of these projects possible. These folks have provided, folks and organizations have provided more general support for the program, where we can use them, direct those funds towards a variety of different projects. And so thank you to all those folks. And at this point, we've used up our hour, but it looked like there were still some questions in the queue. So if anyone wants to stick around and ask a few more questions, we will open it back up and we can take a few more questions for another few minutes.
So we do have some more questions in the queue. So why don't we get at it? First thing is a comment from Dean Edwards. And her comment was, "We are so proud of you." Thank you, Dean Edwards, to our students. Ron Dufort has a question. This is for all as well, so we can go around the room a little bit. Did you establish and maintain one team structure through the whole project, or realize partway through something wasn't working and changed it? Anybody want to take a stab at that?
So our team proposed our project, and we had the group of people that were interested in doing the project kind of, we all figured it out like the year before. So we had defined roles at the beginning of the semester, and those stayed mostly the same throughout the semester. But what did change is the depth of skills that each person had to learn and contribute. So we had a mechanical engineer that did a ton of electrical engineering work, like way deeper than he ever thought he was gonna have to go. And I think everyone also learned a lot more in their specific roles than they intended to. There wasn't a lot of swapping, but there was a lot more depth than we could have expected at the beginning of the year.
Yep. Thank you, Nika. Anybody else?
Oh, we actually had a member change. So we had a plan, and then it wasn't a huge change because they were both the same major, but we brought someone in and someone came out partway through the project. So that was, we had to do a little bit of de-scoping and rearranging of the project to fit those needs.
Yep, that's not unheard of in MSc. It happens once in a while. Thank you, Amber. Anybody else?
Yeah, I know with our team, we kept the same roles throughout the semester, the specific roles, project manager, communications, facilitator. But as the semester progressed, we realized new problems would come up or specific tasks are better suited for certain people. And some people stepped up and others didn't as much. So it kind of just depended as the semester went on. New roles were kind of assigned just based on who could handle the workload of it and who was just able technically to handle that type of work.
Yep. Okay. Thank you, Caleb. Anybody else?
Yeah. One thing that was unique for us is similar to Amber's project. We actually had some new members join. We got we had a member from the industrial design students join us, which was really cool. And it did shift our project focus a little bit in both structure and how we were working on some of our mechanical integration with some of the new industrial design expertise that we could get. And it was really, and as we were going down, we also learned about new skill sets that we could sort of adapt team roles to help people, I guess, shine better and produce a better product.
Yeah. Thank you. Anybody else? So I'm going to go to another question. This is for the whole group again, because I think this is a great one too. This one's from Ken. To all teams, many of you have spoken about non-technical challenges that you had to address. What was the most important soft skill that you build on during your MSD experience? And I feel very strongly about this, so I'm very interested in your answers.
I would say for Lasso, it's presenting and writing. So talking about our work and convincing people that it's important, that we're making progress, etc.
Cool. Thanks, Anthony. Anybody else?
For me, I was going to say communication. I was the communications lead between our team and our customer. So sort of just relaying all the information back and forth was very important. And again, because our team was so big, I forgot who said it, but sort of whatever small decision you make, it'll have a ripple effect down the line. So communicating kind of everything to everybody involved is really important, especially if you have deadlines and things like that.
Right.
For us, I think resilience, again, to all the challenges that I talked about, but also patience. In a lot of other class projects, you have kind of total control over the outcome, and how much effort you put in basically equals the result that you get out. But for this project, there were so many factors that were outside of our control, and so many times that we just had to like wait for things that we literally could not put more effort into getting finished faster, that we had to learn how to be patient and ride through all of those.
Thanks, Nika. Anybody else?
I would say organization, especially like file storing and how to organize all your documents in ways that, you know, everyone can access it and everyone knows how to access it. There was a couple of times where, you know, we would upload something to our Google Drive and other people would have trouble finding it. So eventually we learned the best way to sort folders and get it all correct so that it was easy for everyone to use and we wouldn't waste too much time with kind of knowing where to put all of our files.
Yeah. All kinds of interesting challenges we come up against. Thank you, Amit. Anybody else about the soft skills learnings?
I would say just documentation. That's not something that we think about a lot, but we actually had to think about a lot, and like how Amit said, where to store it, but also what we were writing and how much we were writing. At the end, we ended up with a 60-page document to our client about the future of this project and what we did and how things should go. So that's something that I hadn't had experience with personally.
Okay, thank you, Amber. Anybody else?
Yeah, for our team, it was really, I think it comes down to the team dynamics. It's just, I was fortunate to have a great team where we all really hit it off right from the start, but I think that's something that could really make or break a team, is whether or not they get along or conflict. But fortunately for us, we really got along right from the start, and it allowed us to be very flexible throughout the project.
Thanks, Caleb. Anybody else? So Doreen's got another really good question for the whole team. It's important to engage in lifelong learning. What do you want to learn next? What skills do you want to hone? That's for the whole team.
I would say I'm a mechanical engineering major, or I was, and MSD kind of puts you out of your comfort zone. And I had done a little bit of electrical, simulation type work before, and because our EE was so great, he did a lot, but actually kind of showed me a lot. So I'm super interested in continuing learning more on that side of things, because as a mechanical engineer, you don't usually think about that side of things.
Right. Thank you, Amber.
Yeah, models are great on paper, but in reality, they're typically not very accurate. So machine learning is a big upcoming field. Since 2017, I took 2 classes on it, and I'd really like to start researching merging physics-based concepts and machine learning-based concepts together.
Cool. Thanks, Anthony.
In industrial engineering, we talk a lot about lean manufacturing, but lean is also being increasingly applied to product development. And I've taken a couple of classes at RIT in lean product development and applied some of those concepts to MSD, which was really cool. But my job moving into my career is at a software company. So I'm really interested to see how those same concepts that came all the way from manufacturing through product development and physical products can be applied to software as well.
That's a great learning. Thank you, Nika. Anybody else? So let me ask another question. We're going to wrap this up in a few minutes here. And Mark and Davina asked this question. I think some people actually answered it already, was what did you learn about time management? I know a couple of people mentioned that in some of the answers for some of their other questions.
So our team actually took a pretty aggressive approach to our prototyping, and that turned, so during the first semester, we actually had nearly a working prototype. We had all of our parts machined and in-house, and all that we had to do in the beginning of our second semester was assemble the electronics and start testing. So we were actually able to get, I think, 2 weeks of testing in before we had the campus shut down and access to the lab taken away. So by having a really aggressive approach to keeping ourselves on track and getting a prototype ready so that we could see if our initial thoughts were actually even going to work and we could build off of the results, actually saved us from not being able to test at all. So that was a really valuable thing that we did.
Great, thanks, Emerson. Anybody else want to address the time management question?
Yeah, actually going off of what Emerson said, our group had a very similar approach in that we learned our project was a continuation project. And one of the issues that they had last year was that they spent a lot of time in prototyping, which didn't leave a lot of time for actual testing with the fish and plants. And that resulted in their fish all dying. So we really wanted to make sure that didn't happen with our project. So we had a goal of making sure all prototyping was complete prior to spring break, which we were able to meet. And that would allow us to have testing ability for the rest of the semester afterwards. So really, by allowing us to have that prototype, even with the transition to remote learning, it at least allowed us to have a finished prototype and something that future teams can work on.
Cool. Thanks, Caleb.
There's a quote from Winston Churchill: "Plans are of little importance, but planning is essential." I have to say that Team Lasso very rarely stuck to our plan. But I have to agree with that quote because it really helped us lay out, when we need to do things. And we constantly adjusted that plan as those delays happened.
So it sounds like you were working in an agile mode. Thanks, Anthony. Anybody else?
I think going off of setting more smaller tasks really helped us to improve our time management skills. Especially, it's very easy to say like you want a prototype done in 3 weeks or you want something done in 3 weeks, but when we also were breaking down all the steps that needed to set smaller goals, it also helped us figure out a more realistic time that we could get sections done. And it also even helped us figure out what we needed to do to approach some of those bigger tasks. And as well, using some type of, we use like an online project team Gantt. It was really helpful because we had a big group. It helped us communicate how much of something was done and who could pick it up. And it really helped us kind of know the state of the project and where we were at any given point.
Yeah. Thanks, Amit. Good learnings. Anybody else?
I think going off of what he just said, you do set small goals. The importance of delegating sort of all of the deliverables that you need to reach these goals is really important, especially when you have a large team. You're making sure everyone's sort of, doing the work they need to do to reach those goals, because it's easy to say like, let's have a prototype done in 3 weeks, but when you really break those goals down into small goals and have everybody sort of working towards that large goal with their individual things, it makes things a lot cleaner and organized.
Right. Thanks, Markus. Anybody else? So Chris Fisher's got a comment up here to everybody. I feel your purchasing pain. Thank you, Chris. It gets painful sometimes. But I think we're pretty good in our questions, and I'm going to hand it back to Beth and Kayla at this time.
I think that's a great follow-up to the question about time management, because we've managed to run only 15 minutes over.
That's right.
But thank you again to the participants for all the great questions, and especially thank you to the students who, we should point out again, they actually graduated. So like they've got their grades, they had their celebration ceremony Friday night, so they're totally off the hook, and yet here they are in their kitchens and family rooms on the phone doing one more thing for senior design, which I think it's a testament to the level of dedication that we see, right? That's a great example of how much these students have put into these projects and seeing them through to the very end and then still beyond. So we're really proud of all of you and can't wait to see what you do in the future. And thanks everyone for joining in.
Thank you to Beth and Don and all of our presenters. This was a wonderful, wonderful experience. And thank you to all of our alumni and friends who joined us. With that, we'll conclude the formal program. I want to echo what everyone said about thanking everyone for their ongoing support. We will be emailing out a recap of some of the things that we talked about to all of our attendees, including links to the program and opportunities to get involved. So I encourage all of you who tuned in tonight, if you are interested in getting involved with this program or learning more, please reach out. This is a wonderful, wonderful program, and the students and the faculty are so dedicated and will be happy to answer any questions that you have.
So with that, we'll wish you a good evening, and we hope to see you on campus again sometime soon. Thank you, everyone.